Hi everyone. In this video we're going to look at the graphs of some exponential functions. So let's start out with some examples and then we'll summarize what we learn. Remember, an exponential function is just a base raised to a power where the power can change. So we can plug in anything we want for x. X is any real number. The base is bigger than 0 and it's not equal to 1. So let's say we want to graph the function f of x equals 4 to the x. We can do this by making our usual function table. So if x is 0, say, then f of x is going to be 4 to the 0, which is just 1. If x is 1, then f of x is 4 to the 1, which is just 4. 4 to the 2 is 16. 4 to the 3 is 64. So we can plot these points, 0, 1, 1, 4, 2, 16, and 4, 64 would be way off the page. We can also plug in negative values for x, and of course we could have plugged in 1/2. We can plug in fractional values too. So if we plugged in 1/2, we know we would get 2, so that's an extra point. If I plug in -1, then I get 4 to the -1, which is 1/4. So that's f of -1. F of -2 is going to be 1/16. F of -3 is going to be 1/64, because this one's like 1/4 to the 2, and this one's like 1/4 to the 3. So at -1, my value is a fourth. At -2, my value is a 16th. At -3, it's even smaller. But as I get more and more negative, I'll never actually reach 0. So the graph of this function is going to look something like this. Starts out pretty flat and it rises quite rapidly. Let's check out another example. In this case, we have 4 to the -x. So if I do 4 to the -0, I still get 1. 4, I plug in 1 is going to be 4 to the -1, I get a fourth. I plug in 2, I'm evaluating 4 to the -2, which is a 16th. And I plug in 3, I'm doing 4 to the -3, which is 1/64. When I plug in -1, I get 4 to the -1, which is just 4 to the 1. And this will be 4 to the 2 when I plug in -2, so that's 16. So we can go ahead and plot these points. 0, 1 is that one. 1, 1/4 is about there. 2, 1/16, these values are getting closer and closer to 0. -1, 4. -2, 16. And so on. So this function is rapidly decreasing and flattening out towards 0 as the x values get large. So we can compare these two graphs. This one was 4 to the x, and this one was 4 to the -x. So when we had x, it was increasing. When we had -x, it was decreasing. Both of these go through the point 0, 1, and neither of them go below the x-axis. So let's summarize these ideas. So if we have a to the x, that's akin to our example 4 to the x, where a is bigger than 1. We already know the domain is all real numbers, so we can write that in interval notation as -infinity to infinity. The range is all the possible outputs that we could get, but we can never get a negative number by plugging something in for x here. So the range is going to be from 0 to infinity, all positive numbers. This is going up and up and up, and it never hits 0 on this end. The y-intercept is what happens when we plug in x equals 0. So anytime we plug in 0, we get a to the 0, which is 1. The y-intercept for all the exponential functions will be 0 to the 1, unless we have to multiply this on the outside. But if it's of the form a to the x, then we're good. The x-intercept will be 0, 1. And the asymptote is going to be the line y equals 0, because as x goes toward negative infinity, y goes toward 0. As x goes toward positive infinity, y is going toward infinity, but we still have the asymptote on this end. So no matter what, the graph is going to look something like this, and this intercept is going to be 0, 1. And similarly, if we have a to the minus x, we know that our domain is all real numbers again. Even though it was decreasing, we never drop below the axis, and as x gets more and more negative, the values of f of x get larger and larger. So the range is also 0 to infinity. The y-intercept is also 0, 1, because when I plug 0 in for x, the output will be 1. And the asymptote is the same, y equals 0, because in this case, as x goes to positive infinity, y gets smaller and closer to 0. And so the graph of a to the minus x will always look something like this. And the intercept will be 0, 1. In the next video, we'll talk about how to use these properties as well as the transformations that you learned in Chapter 1 to graph a wider set of exponential functions.